Okay, in this video we are going to look into interactive programming. Now, I've used this technique a lot. It's not very common. They don't teach it in schools, but I use it to teach microcontrollers to beginners, and I'm involved in a maker club, and there's a lot of high school students there and they want to learn about microcontrollers. And when I show them AVR Studio, or if I show them the Arduino IDE and the Arduino Sketch, they get kind of overwhelmed. So what I do, I give them a microcontroller like this here, Arduino Nano, and a USB cable, and they could plug that into the computer, and then they could run a serial terminal program like PuTTY or Teraterm. Then at the OK prompt, they could type in some words that I've given them. So they could type in pin 13 high. You can see the LED comes on pin 13 on Arduino Nano. And if they type pin 13 low, they'll go out. And if they type blink LED, LED will blink. So they get instant feedback, so it's interactive. So I give them a bunch of these little words, little chunks of code. So when they write a program, the program is actually made up of hundreds of little tiny programs called words. So each word is a chunk of code. It's kind of like building with Lego. So if you build with Lego, each Lego block would be a chunk of code, and each Lego block would have a name. And if you type that name at the OK prompt, they'll actually run that piece of code. So that's interactive programming, and we could have a look at the interactive programming on the Arduino Nano. Okay, I have Teraterm up and running on my computer. Now this is a serial terminal program, and you can see I have interactive Arduino running on my microcontroller, and that's my IDE which I wrote so I could do interactive programming. So if I press the reset button on the Nano, there's my reset prompt, and if I type the enter key on the keyboard, there's my OK prompt. So if I type words, there's all the words that I programmed into the microcontroller, and if we look at the bottom part of the screen, so from here down, all those words are written in assembler, so they're very fast. Now the words on the top part, these words here, are written using the assembler words. So they were built using the assembler words. So I could type any of these words at the OK prompt and they'll run independently. Now you can recognize some of these words. There's pin 13. So pin 13, and I use the word high. So pin 13 high turned on the LED on pin 13. And then pin 13 low turned off the LED on pin 13. Now I could have used these two words, LED off, which would turn off the LED, or LED on. So inside those words are the words pin 13 high for LED on. So it just makes it a little bit simpler. We just have to type LED on and LED will come on. Now we can see the word beep right here. So if we type beep at the OK prompt, you can hear a beep in the speaker. If I type beep, and then we'll give it a delay, say 400 milliseconds, and we'll do that many times. So many is a word that we use if we want to run something in a continuous loop. And we'll run in that loop until we hit any key on the keyboard, and we'll come out of that loop and we'll go back to the OK prompt. So anything from the beginning of the line, some beep all the way up to many, will be repeated over and over again. So if I enter that, so I could have many beeps. Or I could have beep, then a delay. Now if we want to do something so many times, so go 5 times, now we'll beep 5 times. Now if we look at the GPIO on the microcontroller, they're on ports B, C, and D on the actual microcontroller. Now pin 13 lives on port B, and it's bit 5. So we could actually look at all the pins on the microcontroller. So if we type .pins, it'll show us all the status of all the pins. So there's all our GPIO pins on the Nano, all the way from pin 0 all the way down to the reset pin, and they're all inputs because when we do a reset on a microcontroller, all the GPIOs are set to inputs. Now if we want to output on pin 13, we're going to make pin 13 an output. So we go pin 13 output, hit enter. Now if we look at the pins, the status, you can see pin 13 is an output. So now we could type pin 13 high, and pin 13 will go high and the LED will come on. Okay, let's stop and recap a bit. So interactively I could get into the microcontroller and I could configure any of the GPIO pins to be either inputs or outputs, and I could either read them or write to them. So here's a summary of some of the commands. So pin 13 output will make pin 13 an output. Then we could go pin 13 high, so we'll drive pin 13 high. and we could type pin 13 low, and it'll drive it low, or we could go pin 13 toggle, and it'll toggle pin 13. Now if we make a GPIO pin as an input, we could go pin 2 input, so pin 2 will be an input. Then we could go pin 2 high question mark, so it actually would read pin 2, and will give us a flag, a true flag if it's high, and a false flag if it's low. Or we could say pin 2 low question mark, and it'll do the same thing. It'll read pin 2, and if it's low, it'll give us a true flag, and if it's high, it will give us a false flag. We go pin 2 pull up, it'll pull a pull up resistor on pin 2, and pin 2 floating, it will take away the pull up resistor. So with these simple commands, interactively, I have total control over the GPIO of my microcontroller. Okay, the ATmega 328P microcontroller has hundreds of configuration registers in RAM, and this is one of them. This is the port B data register, and this is for the port B GPIO. Now this configuration register has 8 bits, and bit 0 is on the very right, and bit 7 is on the very left, and there's the address, hex 25. So from my keyboard interactively, I could read this configuration register in binary, so it would be the same layout as you see on the data sheet. And I could go in and I could set or reset each of the bits independently. So I could set the bit by turning it on, it'd be a 1, or I could reset the bit by turning it off, it'll be a digital 0. So I could go into the microcontroller and I could configure any of the registers on the microcontroller as necessary. Okay, here are the commands that I use to read or write to the configuration registers interactively. So I type on the keyboard the address, then do a right arrow, so that's a negative sign and a greater than sign, and it'll return back the value in the configuration register in binary. Or I could type the address and do a question mark, and it'll return it in either decimal or hex. So here's an example. So bit 5, then the address set. So I will set bit 5 to a digital 1, or bit 5 address reset, and that will reset bit 5 to a digital 0. Now we could read each bit and do a test on it. So bit 5 address set, so it will be a high flag, a true flag if bit 5 is set, and we'll get a false flag if bit 5 is reset. And other way around, bit 5 address reset, so we'll test bit 5 of this address, of this configuration register, and if it's low, it'll give us a true flag, and if it's high, it'll give us a false flag. So here's an example that we could turn on the LED on pin 13 on the Arduino Nano. So bit 5 port B set, it'll turn on the LED on pin 13, or bit 5 port B set question mark, it'll actually read the bit and it'll actually tell us if it's on or off. Okay, so that was my primer on interactive programming. Now this technique is not for everybody, so if you're an experienced programmer and you do a lot of programming on AVR microcontrollers, you could just continue doing what you were doing. But I've used this technique on the ARM Blue Pill, the MSP430, the Parallax Propeller. So basically the main reason why I made this video is because people ask me for code for my projects, and I basically tell them there's no code, I've done it interactively. So if you want some examples of this interactive programming, every one of my videos that involves code or involves a microcontroller, I'm using this technique. So you can look back at any of my old videos and you could see the code there on interactive programming. So if you're a beginner, it's a good way to start. You get right into the workings of the microcontroller, right down to the register level. So if you're a beginner, you could consider using interactive programming.